Hello, algebra classes. We're going to take a look at 9.6D guided practice together. In this lesson, we're continuing on with solving quadratic equations using given methods. We're going to get really solid at when we are told which method to use to be able to implement that and find a good solution before we move on into figuring out which solution method we want to use. All right, so we're going to be working with some problems that we find back in our extra practice section of our textbook. So this will be an extra practice problem labeled number 22. So we're going to call this guided practice 22. And we're to solve this by factoring 3b squared plus 9b equals 0. And we've seen problems like this before, so this is a little bit of a review. So we notice we can use greatest common factoring to solve this equation. We can divide both 3 and 9 by 3, and we can divide both b squared and b by b. So we're going to factor out 3b, and since 3b times b is 3b squared, and since 3b times positive 3 is 9b, we've written this now in factored form using greatest common factoring. We recognize 3b as a factor, so I can enclose it in parentheses. B plus 3 is the other factor, and we are equal to 0 here. And now we are ready to set each factor equal to 0. So 3b divided by 3 is equal to 0 over 3, so that gives us b is equal to 0. And over here, we're going to subtract 3 on both sides, setting the second factor equal to 0. Subtracting 3 gives us b is negative 3. So we've solved this by using greatest common factoring, and we arrived at the solution b is 0 or negative 3. All right, so remember that greatest common factoring is something we always want to utilize when it works. But we also want to consider quadratic factoring when it works. And guided practice 46 is going to remind us that we can solve by using quadratic factoring here. So we have this equation given to us, 3p squared minus 28 equals 17p. We recognize it as a quadratic equation. We see the p squared, but we're not equal to 0. And since we are going to be using factoring, we need to be in standard form equal to 0 to use that factoring. There is no greatest common factoring that will work here. There is no number bigger than 1 that we can divide 3, 20, and 17 by, and not all the terms have a variable p. So first we're going to get equal to 0 by subtracting 17p on both sides, and we're going to rewrite this then in standard form order, and we're going to use our quadratic factoring only on this particular problem. So using our quadratic factoring, we notice that 3p times p is 3p squared. 4 times negative 7 is negative 28, and our diagonals will create this negative 17p we need. Negative 20p on this diagonal plus 4p equals negative 17p. So we are going to now use this information to rewrite our trinomial in factored form. So 3p plus 4 times p minus 7 is equal to 0. Set each of those factors equal to 0 and solve for p. So here we are setting 3p plus 4 equals 0, and here we are setting p minus 7 equal to 0. On this equation, subtract 4 on both sides, and then divide both sides by 3, and you'll have p is equal to negative 4/3. Here, p minus 7 is equal to 0, add 7 to both sides, and we'll find that p is 7. And we have now finished solving this equation by factoring. So remember, there are two types of factoring that we can use when we are told to use factoring. One is greatest common factoring. Another method is using quadratic factoring, and they can be used simultaneously in the same equation if it applies in that equation. In the two equations we've worked so far, we used different factoring methods because those factoring methods worked on those particular equations. Okay, guide practice 23. Let's solve by taking the square root and then rounding to the nearest hundredth. This one is a good equation to solve by taking the square root because we only see a squared term. We see m squared. We don't see any m's. When you see only squared terms on the variable and we don't see any of just the variable by itself, then taking the square root will be a really efficient method to solve the equation. So being told to take the solve by taking the square root is a really good choice here. Start by adding 5 to both sides. We're trying to get m squared by itself, so we can take the square root. That's why we're adding 5 to both sides. That gives us 5m squared is equal to 15. Divide both sides by 5, and that gives us m squared is equal to 3. Then take the square root of both sides. Once we have the squared term by itself, that's when we want to take the square root of both sides, and we get both a positive and a negative root. We use our calculator to find out what the square root of 3 is. And we see a lot on our display, but all we need is rounded to the nearest hundredth. So that 2 tells us to round that 3 down, so it stays the same. So m is both positive or negative 1.73. Here's another problem where we're asked to solve by taking the square root. We're going to end up with no solution on this problem because we're going to try to take the square root of a negative number, which doesn't give us a valid response in the real number system. So how do we do that? All right, well, we're going to want to get t squared by itself, so we can take the square root, subtract 2 on both sides. That gives us negative 5t squared equals 2. Divide both sides by negative 5, and that gives us t squared equals 2 over negative 5. Then we try to take the square root of both sides to find out what t is, but we can't find an answer to what is the square root of 2 over negative 5. There is no real number solution to the square root of a negative number. So the fact that we see plus minus outside, that doesn't have any relevance since there is no number that we can replace the square root of 2 over negative 5 with, so t is no solution. Again, this is a really good problem to use taking the square root as a method because we see t squared, but we don't see any t's. So if you see x squareds and x's, taking the square root isn't a good choice. But if you just see x squareds or any variable squareds, taking the square root is a really efficient method to solve your equation. All right, guided practice 28. This one says to solve by completing the square. Not necessarily the most efficient method, but it's a method that we're told to use, so we will here. All right, so remember when we are completing the square, we open up a box on both sides. We're going to add in the same number to both sides. To figure out what goes in the box, we take the coefficient on, in this case, the g term, and divide it by 2. That gives us negative 5. Square negative 5 and get 25, so that goes in both boxes. Rewrite your perfect square trinomial that you just built as g minus 5 squared, because g minus 5 times g minus 5 is g squared minus 10g plus 25. And then over here, 24 plus 25 is 49. Now take the square root of both sides because we have just the squared term by itself. So taking the square root of both sides will give us both a positive and a negative root. So we get g minus 5 equals positive or negative 7. Add 5 to both sides and get g is equal to 5 plus or minus 7. And that breaks down into 5 plus 7, which is 12, and 5 minus 7, which is negative 2. So no need for a calculator on this problem because it worked out to be a perfect square situation. All right, guided practice 35. This will be our final problem that we're going to be working together to practice solving quadratic equations by being told which method we should use. All right, so this one is a good choice to solve by the quadratic formula because it does not factor, and you can't take the square root to solve it because you see both x squareds and x's. So when those two easy methods of factoring and taking the square root don't work, solving by the quadratic formula is usually your next most efficient method of choice. So to solve this quadratic equation, using the quadratic formula, we will need to be equal to 0. We'll need to be in standard form so that we can see our a, b, and c, so we can actually plug into our quadratic formula here. So a is 5, b is negative 4, c is negative 2, which we can easily see once we are in standard form. Now plugging into the quadratic formula, we're going to write down the opposite of b. The opposite of negative 4 is 4, plus or minus the square root of b squared. Remember, when we are squaring a negative number, we need to enclose that negative number in parentheses before we square it. Minus 4 times a, which is 5, c, which is negative 2, all over 2 times a. And our a is 5 here. Okay, let's simplify it all. So 4 plus or minus, negative 4 squared is 16. And we are going to subtract the negatives. We're actually going to add. So 4 times 5 times 2 is 40. And when I saw the minus and the negative, I knew that it's like two negatives that cancel each other out. So that's how I knew to add. And in the bottom, 2 times 5 is 10. And we're still extending that fraction bar all the way across. All right, 16 plus 40 is 56. So we have x is equal to 4 plus or minus root 56 over 10. And then we can use a calculator to find the approximate value of root 56, and that to the nearest hundredth is 7.48. Again, we're losing a little accuracy by rounding at this point, but for what we're doing, that's okay. And then we're going to break this into the two calculations that we need to work out to solve this. So 4 plus 7.48 over 10, 4 minus 7.48 over 10. You can use a calculator to work those out. You have more numbers as digits in your display than you need because we're rounding to the nearest hundredth. So We're going to bump that 4 up to 5 because we see an 8 to the right of it, and that 4 is going to bump up to a 5 because we see an 8 to the right of it. So here's our final results. 1.15 and negative 0.35 are the approximate values that solve this quadratic equation. Okay, now it's time for you to go ahead and move on to the homework portion of this lesson, and we'll see you next time.